So to see if it's a tree, the first thing we need to do is to see if the graph is connected. Looking through the 8 graphs, you can see that the 4th graph is not connected. Recoloring the edges, you can see that these 3 nodes are not connected to these 3 nodes. So this one can't be a tree. All the other graphs are connected. The next thing we need to look for are cycles. The 2nd graph is a ring, and it's obviously a cycle. And in the 7th graph, there's a cycle between these 4 nodes connected by the edges in pink. And so that can't be a tree. And so that leaves these other 5 nodes, all of which are trees. Now some of these, like this one, it's kind of obvious that it looks like a tree, but the 8th graph doesn't really look like a tree. Why do we call it a tree graph? What we can do is number and rearrange the nodes to make it look like a tree. There's 7 nodes in this graph, and I've numbered them 0 through 6. And let's start rearranging this. Let's start with node 6. Now node 6 is connected to node 2, so we'll draw that connection. And node 6 is also connected to node 1, so there's that edge. And you can see that node 2 is connected to node 4, and node 5. And so we can draw in those nodes and the edges. And then node 1 is connected to node 0 and node 3. So here are those nodes and edges drawn in. We can see that we can transform this graph, which doesn't look like a tree at all, into something that looks a little bit more like a tree. It branches out. So hopefully that gives you some idea of why we call these tree graphs.